So you all see this big link on here. Hopefully you can see it in the back of the room. This is just a Gotomeeting that will show you guys the code and the slides and stuff that I will be going through. This is so you all can hopefully see it, because I'm going to be in Vim for about 25 minutes of this, and it might be a little bit on the small side. So if you're having trouble seeing the screens, feel free to hop into this. It's tinyurl.com/u2-can-believe. It's Gotomeeting. Just put in your name, and it will pop up Gotomeeting. Some of you are web developers and saying, I don't want to install Gotomeeting. That's okay, I understand that. Just if you don't mind straining your eyes. So thanks for coming out to my talk, where I hope that with this one weird way to rewrite closures, I can restore your faith in native JavaScript closures. The rest of this time, don't believe anything I say. That is my only caveat. So with that, before we get into the mind-blowing business, I'll tell you just a quick little bit about myself. I'm Jonathan Martin. I work at the Big Nerd Ranch up in Atlanta, Georgia. And I work as a back-end and front-end developer, and also as an instructor. If you happen to be up near the Atlanta campus, we'd love to have you. We probably have some swag. At the end of this talk, Todd and myself, who also works at Big Nerd Ranch at the front table, we will be out at one of the booths or tables out there. If you're interested in getting any koozies or nerdy glasses, any of that stuff, we have it all. So everyone nowadays, when they talk about JavaScript, they talk about scopes and closures as being the big thing that make JavaScript so powerful. But really, for years, people have survived without this memory-intensive complication on the JavaScript runtime. Anytime you needed to avoid variable name shadowing or global or any kind of variable name collisions, all you needed to do was use unique global variable names. Maybe you prefixed your variable names with some unknown, unheard of function name. There's all kinds of techniques people used. So the example I give, first of all, is Fortran. Fortran introduced in 1957. That was back when a corrupted computer program probably meant you got mustard or something on your punch card. Well, nowadays we don't have that excuse for a corrupted program. But considering that we still, to this day, rely on all these super optimized math algorithms that are written in Fortran, I'd say they did pretty well without any sort of local variables or closures. Then x86 assembly, 1978, in my opinion, one of the first real languages, because you could write hello world and other insignificant things like operating systems in it. They did all this just fine without any concept of closures or local variables. All that's just kind of modern propaganda that gets thrown at us all day. Even Ruby. Ruby was introduced in 1995, and we all know it really just came as a last-ditch effort to save object-oriented programming in the wake of the closure craze. Well, thanks to Ruby, object-oriented programming apparently lives on, and people still write things with classes instead of closures, which is totally the way to do it nowadays. But apparently that's frowned upon by Twitter. So to the point, you don't actually need closures or local variables or any of that nonsense. However, closures tend, because they were tacked on at the last minute into JavaScript, they're slower than a Java GUI. So we spend most of our time waiting for closures to execute. We have this thing called function overhead because it's got to initialize all these variables on the stack. It's all this nonsense attached to functions, when really it would be so much faster if we could do this all on the heap, all at runtime dynamically. So typically, when we want to improve these sorts of things, we rewrite them. So React's virtual DOM comes to mind. It completely rewrote the DOM and completely replaces it, so you don't need the DOM anymore. And it makes everything so much faster. Well, what if we did the same thing with closures? Because who here has used a closure? Who here has used local variables? So you guys are probably plaguing 99.9% of your code with this memory-intensive complication on the runtime engine. It's all nonsense. Back in the day, we just used global variables, which are really just registers. Registers are about as fast as you can get. It's only 1 or 2 machine instructions away. So to address the underlying performance problems in JavaScript, we just need to replace it entirely ourselves. And we're going to rewrite it all by ourselves. And by the way, this will also give us a chance to completely redo the syntax, because, I mean, really, who remembers the var keyword every time without JSHint's not so subtle proddings? So in the spirit of IE compatibility modes, we are going to develop our own polyfill for those closure-bound developer friends of ours who are still stuck in all this pure function and Y Combinator propaganda, who knows where it came from. And we're going to bring them back to the simplicity of global variables and registers, all in JavaScript. Now, before we go on this little journey, we do have some rules we have to follow. Otherwise, it would just be a free-for-all. So any code that is going to be using this polyfill has to do 5 things. First off, it is not allowed to use any native local variables. It is not allowed to use native local variable assignment or create functions with parameters. or any sort of arguments. Now, those of you who are used to doing parameters, it's really just local variables, after all, inside the function that get bound to some value. So that's a local variable in and of itself. We'll still have slow functions. So we're going to nuke all of that. You can't do any of that in your code. However, the implementation, as we will see, is allowed to use some of those. Second, you may not attach any data directly to a function object. No sort of memoization, no cache objects, none of that. Functions are going to be amnesic, or the terminology we'll see is amnesic function body. We are allowed to do a few things. We are allowed to access that one weird global variable, and then we can use amnesic function bodies just to wrap around buckets of code. Again, these buckets of code are not allowed to use local variables of any sort or parameters, so I call them amnesic because they don't remember anything about their scoping rules, which are built into JavaScript. They're not allowed to do any of that, so they will be amnesic, just buckets of statements. And then finally, just to make things a little bit shorter for demo, you are allowed to use shortcut local variables that will give you access to a few functions, as we will see later on, because they could just be expanded to the full global variable name. Some of you may remember this convention if you watched Programming with Nothing, which you mentioned at the beginning of the talk. So that takes a similar convention where you can use constants just to simplify the code, but at the end it can all be collapsed and not even use any sort of local variable names. So we're going to do all that. So with these rules, we're going to make substitutions like this. The first line you see is var local equals some value. This is going to be replaced with a mysterious function called s for set. It will take in the name of a local variable to which we want to assign, and then that value. So s will exactly replace the variable assignment we're used to. Anytime we want to do a lookup, we call g, which is for g for get, which takes in the name of the local variable and just returns the value in the current scope, exactly the same as variable lookup. And anytime we have a function expression assigned to a variable, we will replace all of that with a call to f. F takes in the name of the local variable to which we would be assigning this function, the list of parameters as an array, and then that amnesic function body. Notice that the function body has no parameters. It's not allowed to do this. We're just using functions as a way to wrap around a bunch of code. So with this in mind, we're going to take an example that looks like this. This is a canonical example of how closures work in JavaScript. In this case, we have an outer function, which when invoked, returns an inner function, which when invoked, prints out the values of x, y, and z. Now, the prudent among you will notice that the inner function shadows the x variable of the outer one. So if you were to evaluate what that bottom statement would run, it would execute outer, passing in 1 and 2, and inner, passing in 3 and 4. And you should get an output of 3, 2, 4, because it prints out x, and x is shadowed. So the second time we pass in the value of x into the inner function, that's going to be what gets printed. So remember, the output of this should be 3, 2, 4. And with our little transformation we saw on the last slide, we're going to make this look so much better. We're going to replace it with this. We'll call our f function, our g function, and our s function. So notice in here, there is no reference to native local variables or functions with parameters. All we have are those 3 setter, getter, and function helpers. So bear this in mind as we start developing it, because the next step is to, in 70 lines of code, we're going to re-implement this, and all we'll be exposing are the s, f, and g functions. So at this point, I'm going to move to something very risky. We're going to live code this in Vim. First difficulty we will face is getting this large enough to see. I need another screen. So if you guys can't read this, especially as you get back a few rows, go ahead and go launch up that Gotomeeting. I know it's a plugin. Who wants a plugin? But WebRTC won't work on these firewalls, unfortunately. So you should be able to follow along then. So I'm going to be taking a test-driven approach to doing all of this, which means I've cheated. Beforehand, I've written out all these specs which describe the behavior that I want out of this. I'm using Mocha in Chai. I have not yet been instructed on the proper pronunciation. So first off, we're going to look at how a scope should work for a global context. So whenever you think about scopes, we're thinking about local variables. Back in the days of x86 and Fortran, all you had was the global scope, variables that can be accessed from anywhere in your program. So it's very easy to describe these, so let me walk you through it. First off, we have a little bit of setup functionality for every test. We create a scope object. This scope object is going to be responsible for keeping track of local variables that have been created, along with the values they are set to. Now, again, here are our shortcut functions, which is just mapping S to the set function on scope and G to the get function on scope. These are just shortcuts, so we're not violating that rule. We're taking advantage of Rule 5. Then our first test, which insists that a scope which works like a global context should be able to set a variable, in this case, the variable x to 1, and then if we go to look it up with the G function, it should return that same value. And if we try to look up a variable that did not exist, we should get undefined back. So in fact, if we run this spec, we should see that it fails. Well, first off, it says that scope isn't even defined. So first thing we need to do, we need to go define this. So let's go over to this other file. And I'm just going to use the revealing module pattern to keep things clean. So I'm going to create a scoping object. And this scope object is going to expose itself. Wow. It's going to expose a constructor called scope. And this constructor isn't really going to do anything. It's only going to create one instance variable, which is going to be underscore dict. Dict for dictionary. So this dictionary is going to map from all local variable names we know about to their values in this particular scope. This represents just one scope. So we've got that set up. Let's run the specs now and see what happens now. We moved a little bit further. Cannot read property bind of undefined. It's because we don't yet have those get and set functions. So let's just go ahead and write those. Those are pretty easy to write. So get, as you will recall, takes in the name of the local variable we want to look up and returns it. So this is a simple property lookup. We'll look up in the dictionary the value by the name of key. And set is going to be almost exactly the same. Set is going to take in a key as well as a value. And then instead of returning it, it's going to set it to it. Nothing too unusual here. If we run this spec, and I keep going to the wrong window, if I run it, we now see that our first spec, which is a scope that works as a global context, should work. So awesome. We have our first spec passing, and we have the concept of global context, which is not really groundbreaking. We've had that since x86, Fortran, name any other language. We had this with registers. So let's go a little bit further. We'll go to our next set of specs. So that was for a global context. Now we're going to enable this for what I call a context. So some of you may have done some graphics programming before. In graphics programming, whenever you want to paint something, you typically push on a context, you change the stroke, maybe the width, the color, a few other properties, and then you do some work. And then when you're done doing that work, you pop the context. You do this so that way the parent function that called you doesn't get into any side effects because of all the work that you wanted to do in your own little function. So push and pop, very often in graphics programming, would be called at the boundaries of a function. Well, in JavaScript, our functions do exactly that. Functions act as boundaries between different scopes. So before we get to that point, we're just going to go ahead and create push and pop functions. So notice we have two new aliases here. And let's go over and implement those. So hopefully now that we've enabled these, we should see that we have some failing specs. So it says scope for context. First off, it says it cannot read property bind. This means that we haven't defined those push and pop methods at all yet. So let's fix this. We'll define a push. We're not even going to fill out its implementation yet. Like all good test-driven developers, we want to make sure our tests fail first and take it one step at a time. So now that we've got push and pop, we should see that some of these tests look a little bit more detailed now because now our setup block can actually run. And we have two tests passing. The first test is that a scope should inherit variables from outer contexts. Well, obviously, at this point, we've only done global contexts, so if you were to create a new scope by doing a push, that push is a no-op, so we're still in the global context. So of course, we inherit variables from outer contexts. And the last one is a little bit more related to something later on, but we'll want to make sure that one passes as well. The first and third tests are failing, though. It says that it should be able to isolate variables from outer context, which means that whenever we supposedly push a new context, we're leaking data into the external environment. It's because at this point, we're only dealing with global contexts. We haven't implemented local contexts. And then the final one, variable shadowing. This says that if we have two variables of the same name, that if we set the variable by the same name in the inner scope, it should not override that when we go back to the outer scope. This is the isolation part. So both of these tests fail. So let's go back and actually make these sort of pass. We're going to set this .dictionary, which again is a map from all the local variables in the scope to its value, and set it to a brand new object. And I'm going to cheat here. Anytime we go to pop a context, we'll just set it to a brand new object as well. Let's see what happens now. So we have our first spec passing. Variables are now isolated, but we broke everything else. So we've taken a step backwards. So at this point, we actually have to get into the meat of this whole talk, which is going to be, how are we going to make scopes that can inherit variables from other scopes? Because this is essentially what happens in closures. A closure gets a scope, and that scope has default values from the external environment. But if we go to override it, then we don't override the parent's value. We actually create a new variable in that scope. So I use the word inheritance on purpose. That should trigger a certain JavaScript concept in our minds. And here's where we get to the buzzword, prototypes. What we want to do is we want to create an object which inherits all of the default values from the parent scope, or the parent context at this point, but be able to override those without influencing the parent. The best way to do this is we're going to use Douglas Crockford's method of prototypical inheritance. So whenever we go to push on a new context, instead of setting it to a new object, we are going to call a mysterious method we will define called forkDict. This forkDict method will take the current dictionary of local variables and create an object which inherits from it through the prototype chain, which means that anytime we try to do a lookup for a variable of a name that was in a parent context, we'll get it. But if we try to set it, then we'll get a completely new variable without changing the parent. So now that we're calling forkDict, we should also probably do something about pop, because right now pop is just creating a new object. The way we'll get around this is we'll take a look at the current dictionary, and then we'll keep track later on with a dunderscore parent. We'll see exactly what that means, but dunder parent is going to remember the object that existed before we pushed. So let's go implement that method. We'll do it as a private looking method, so we'll do underscore forkDict. It'll take in no arguments, and at this point, a lot of you may gloss over, or some of you may be like, oh, I know this pattern. It's Douglas Crockford's method of prototypical inheritance with a little bit of salt thrown in. So we're going to create a local variable here and just assign it to the current dictionary of local variables. And then we're going to start doing the pattern, which is we create a donor constructor function. We're just using this for the prototypical chain. This function will never actually be invoked. And then we're going to set the prototype property on this function. To do this, we'll use an ES5 feature, which is object.create. This does kind of another level of inheritance, but you could code this all as well. It's just, this saves me a little bit of time. So let's call object.createDict, and we'll set the function's prototype to that. Now we need to set a few methods on the prototype. Let's set the constructor, just because we're going to be nice. Let's see. Constructor equals f, and then f.prototype. We need a way to keep track of what the previous dictionary or the previous scope was. So we're going to set that dunder parent variable to dict. That way, later on, when we go to pop, we can go back to that previous context. And then to finish off Douglas Crockford's pattern, we just need to return a function created by that constructor. So that was quite a lot happening. Let's see if this actually works, which is why we have specs. Yes, so now we have our scope object, and it works like local context sees, kind of like in the graphics idea of push and pop. Now, nowhere in your JavaScript code do you see calls to push and pop. You see functions being created. So now we're going to actually implement that f function we saw in the slides earlier, which will create a function expression and assign it to a local variable. So let's go to our next set of specs. We'll disable those for now, and we'll go down to the next set, which is down here. We'll call scopes that act like this nested ifs. So nested ifs, if you think about it, are a whole lot like calling push and pop. Whenever you enter a function, you immediately get a new scope, which inherits from its previous scope. And as soon as you finish executing that function and pop up the stack, then you get the previous scope, and that's like calling pop. So in this case, we just want to use nicer syntax. Notice that we've gotten rid of push and pop, and we just have S, G, and F. F is going to be a new helper we'll write called func. And then we have a bunch of specs describing how this should work. Let's see if this even works to begin with. Well, not at all. It says cannot read property bind. We haven't even written the func helper. So let's go give this a try. So recall that the func helper, or f for the shorthand, is supposed to take in the name of the local variable to which we want to assign this new function expression. It takes in a list of the parameters by name that normally we would put in the function and then in between the parentheses. And then it takes that amnesic function body. I'm going to call it body here just so it's obvious that it doesn't have any memory of anything else. We're basically just using functions as a way to get some code into this environment, but it doesn't remember anything about its environment or where it was created as it pertains to the native scoping mechanism. So in here, I'll need to do a few things. First off, I know I'm going to need to save the value of this because we're going to call some methods. And then what I want to do is I want to expose this function that's being created as a local variable. So I'm calling this dot set, and I'll set it to the name that was passed in. And then I'm going to pass it in the function that I want to set this local variable to. Now, I can't just pass in body. If I pass in body at this point, body doesn't even remember who its parameters are. It doesn't remember anything about its scope. What I really need to be able to do is do a little bit of setup functionality first in a wrapper function and have that wrapper function then call our amnesic function body. So we'll do exactly that. We'll create a function wrapper. And in here, we're going to need to do a few things. First off, we know we'll need to invoke body, because otherwise our code would never get run. But then we also need to deal with the context keys. We need to call push to get a new workspace, and then just below it we need to do a pop. Now for this to be really useful, we need return values, so we're going to save off whatever the body returned, and at the very end return that result. This is pretty much it. There's one last thing we haven't done though, which is params. Notice we're not using it anywhere. Params gives us that list of local variables which get passed into a function. That's essentially, function parameters are just a convenience on top of it. Well, we want that convenience, so what we'd like to do is, after we've gotten a brand new context, we want to go over every parameter and look in the JavaScript arguments object that was passed into this function wrapper. Oops, let's go back where we were. We want to set every single local variable in this new scope to all the values that were passed in as parameters. That's going to be a lot of code to type here, though, so I'm going to create a little helper. This helper will take in an array of params and a corresponding array of parameter values, which is going to be arguments. And I'm going to use the arguments object here that JavaScript provides to every function. Very performant, I assure you. Let's go a little bit further, and let's go implement this args helper. So we'll do proto, scope, args, and it takes in the names of the local variables along with their values. And this is just essentially a mass assignment operation. So we're just going to for loop over all of the names, and then we're going to call this dot set for every single one of them. So names I, and then values I. That was a lot of typing. Let's see if any of this works. It passes. So now we have our closure implementation working whenever we build nested ifs. But we have one last class, and this is probably the hardest class to deal with because it will completely change our code and break all of our assumptions. So let's go down here to the bottom, to the last set. Now if you look in here, we've got the same SF and G, but you'll notice that example that I wrote earlier, which is we're doing an outer function, which returns an inner function, which returns the values of x, y, and z. And then we invoke that function outside of its definition context. This is where JavaScript's idea of closures becomes very powerful, is a closure remembers its definition time scope, not its execution scope. So let's see if this runs. It says it fails. It says that it expected to get 3, 2, 4, but instead it got 3 undefined 4. So this means that somewhere we were accessing a scope we didn't expect, at least if we were thinking of this as regular JavaScript. And in fact, we made this error earlier. If we go back to func, look at where this .push is being called. We're calling it inside the function wrapper, which means that we're calling this .push at the same time we invoke this body, not at the time we define this function. Well, recall that this .push is going to look at the current scope and fork off of it. So this means that we're not actually keeping track of the scope from when this function was defined. We're actually looking at the scope and forking off of it at the time the function is invoked. Well, this is not at all how JavaScript's closures work. In JavaScript, it's based on where you define the function, not where it's executed. So to fix this, we kind of need to move the this.push statement up a level. We need to move it to the time that we call our helper to define this function. But that's not quite it either, because as soon as we call this.push, it will change scope. And we don't want to change scope until we actually execute the code. So what we really need is a way to keep track of what the current scope is at the time we're defining this function, pre-fork it, and then let that rest for a while. We need to save it off somewhere so that way when this function does get executed, it can resurrect that scope by doing a scope.push. Well, let's just pseudocode this for a little bit. We'll do this, and we'll suppose that we have some way to get the scope for the current closure. And assuming that we get that scope back, which is going to be a scope object, we'll do fork, which is just going to be an inheritance. Now, does anyone start to feel a little bit uncomfortable? We're at 50 lines of code. We don't have this actually working yet, and we have a lot of functionality in this one scope class, or revealing module pattern if you prefer. This makes me uncomfortable. We have the idea of a scope, which is supposed to represent just one scope, but somehow we're supposed to keep track of all the scopes in memory so we can assign it to functions. That sounds more like we need another class, maybe. So in fact, let's do that. Back in our tests, I preemptively did this. We're going to create a closure registry. This closure registry is going to keep track of all the scope objects we create anytime we do a function, and it will collaborate with all these different objects. So at the very top of our current file, we're going to create a closure registry. We'll use the same revealing model pattern. So we need to return the closure registry, and then we need to create our constructor. Now this constructor won't take in anything right now, but it does need to keep a registry. This registry is going to be essentially the entire environment of our JavaScript runtime. It's going to map from all of the current functions that have been created to their corresponding scope. Some of you are already thinking, how are we going to do that? You can't use a function as a key into a variable. Bear with me. So we'll set this up, and we'll need a way to keep track of what closure is currently executing. And we'll see just why in a moment. So now we can start moving some functionality around. Push, pop, and func really don't belong here. They really belong in a closure registry because they all deal with creating new scopes. So let's put that up here. We don't really know how push and pop are going to work in this new context yet, but we do know how the function helper is going to work. We'll just change this out so it's closure registry. And what we would like to do is to implement this scope for current closure method. And then when we call push, instead of letting it fork off a new scope at runtime, we're going to pass it in. Now, some of you may be thinking, he's cheating, he's using local variables. Yes, you can use local variables in the implementation, just not in your consuming code. That would be quite a bit more difficult, admittedly, if not impossible. I have yet to explore that. So when we call this .push, we'll push in that scope that we calculated at definition time when we call the f helper. So we've got quite a few things we don't really know about. We don't know how we're going to implement this scope for current closure. We don't really know how that's going to work yet. And we don't know how push and pop are going to work. So now is where we get a chance to make a fun little observation. Whenever our JavaScript is executing, there's only one scope active at any given time. This is a single-threaded language, so whenever we enter a function, we are using the scope for that function. Seems pretty simple. So that means that whenever we start a new function, we push on the active scope, kind of like contexts, and as soon as that function finishes, we pop it off. What do we pop off back to? Whatever the previous function was that called this function. We can guarantee this because we no longer let people arbitrarily call push and pop. We always ensure that every function calls push at the beginning and pop at the end. That means that we actually don't need to keep track of every function we've ever created and map it to a scope. We really just need a stack of scopes. So I'm going to turn registry into an object, or excuse me, into an array. And this array is going to keep track of what the current scope is and all previous scopes at execution time. So that actually makes some of this code a lot easier. For example, we know that with a stack, the current item is going to be the last item. So we'll just index into whatever the current scope is. We'll look at the last item on top and return it. So now we have scope for current closure defined. Now maybe we can go write these push and pop methods, because push and pop will need to push a brand new scope at execution time. So nowadays, push is going to be taking in the exact scope. So we actually don't need all this complicated for-dict logic. That's all going to be below. And we don't really need pop. Now, someone might recognize these method names and notice that I kind of saved us a step. Push and pop. These are methods on a standard JavaScript array, and they do exactly the same thing as what we've written here, except that push takes in an item to push. So we could write all these out, and it'd be a lot of boilerplate code, but we can actually save ourselves a few steps. I've written a little helper. You can go check out the repo, which I'll post up later, which is called delegate. It takes in a list of functions that we'd like to create on the closure registry prototype. So not get set, push and pop. And then it takes in a few other arguments. It lets us say where to create these functions. So I'm going to say on the closure registry.prototype. So it's just going to add these. And then I want it to delegate any calls to those straight on to whatever the current to whatever the current scope is. So I'll call this .scope for current closure and return that. So again, delegate is basically just creating push and pop methods for us on the closure registry prototype, but it just delegates to whatever the current scope is, which is what is on top of the registry. Now there's one other thing we haven't done here. We're still in our func implementation. We're calling set and args. We're calling it on this, which is the closure registry. It doesn't actually have access to these methods yet. They're back on the scope. Well, instead of copying those over or rewriting an implementation here, I'm going to make use of my little delegate helper again. I'm going to delegate any calls to get, set, and args straight on to the registry. And that should work. So now whenever someone in closure registry tries to call get, set, or args, it'll just delegate straight on to whatever the current closure is. So this looks really, really close. Let's see if it runs now. Cannot read property fork of undefined. Well, we had one other thing we forgot to do. So this means that scope for current closure is at some point returning undefined when we invoke it. We don't want that. That's going to be problematic. That's because we start out our idea of scopes and closures without a global scope. Notice that the registry stack starts out empty. Well, we need to fix that. All we need to do then is add a starting condition, which is going to be to create a brand new scope. And this is going to be our global scope, just to start things off, so we have a place to attach all these function bodies later on. So we look really close to being done, but we kind of reference this fork function without defining it. Somehow I think that's going to be problematic. So let's go on a little bit further and just write this last method. Scope fork takes in no arguments, and all it will do is it's going to create a brand new scope object, so it is a constructor of sorts, and initialize it to a dictionary using fortdict. So this just returns a brand new scope object whose dictionary of local variables inherits from this current scope. But of course, our scope constructor doesn't take in a default dictionary, so we'll have to do something like this so it can be taken in. That was a lot of code. Let's see if it works. Nope, not quite yet. Let's see what we did wrong. This ._registry. This one. .length, thank you. All right, let's see what's going on now. Cannot read property apply of undefined. Let's see where our other issue is. No changes there. To this .registry, that looks correct. Scope for current closure, that looks fine. When in doubt, check git. There's the issue. I swapped these up a little bit. It runs. So let's see how many lines of code this was. 68 lines of code. So in less than 70, in 68 lines of code, and you can actually trim this down to 67, we have our own implementation of local variables and closures in JavaScript. So you too can do this. Now some of you may be asking, can I actually use this? Where would I go to use this? And how can I mass convert all of my code over to use this much more performant version of closures? Well, there's a transpiler for it. Go to GitHub, github.com/nibbler, that's 6 consonants, /closures, and you can go try this particular demo online, where you drop in any code that use variable assignments and lookups, or function assignments, and we'll convert it over to the appropriate code, which uses F, S, and G. Yes, this is a transpiler. It is not doing regular expression mass substitutions. So this should generate usable code if you don't hit any of the edge conditions that I explicitly mark out. So your next question may be, should I actually use this? Well, JavaScript in JavaScript is a great way to get brownie points with your next employer. So next time you're thinking about writing some uninteresting legacy code at your next job, just so you can flee from it later on, drop in your own implementation of closures, and you'll have guaranteed job security. And then your final question may really be, is this the future of performant JavaScript? And this is the first step. The next step is going to be to re-implement prototypes with closures, at which point we'll get an even faster tick in our benchmarks. And so the idea is to use eval scripts to get this working, and I think the other one was to completely drop out prototypes, and we're going to do that with just plain old closures, which are evaluating a script. So totally, we're just going to swap out these two concepts because prototypes are faster at closures and closures are faster at prototypes. So with that, I think you have all you need to make your code much more performant. Thanks, guys.